Alright, let's get taking up some homework here. Firstly, we need to complete our net ionic equation stuff. So the equation is already balanced, so we'll take sodium hydroxide and make it into sodium and hydroxide. Aqueous, aqueous. Plus HCl breaks up into H aqueous and Cl aqueous. Arrow. We'll leave our H2O as H2O because that's a liquid. And lastly, we'll break up sodium chloride into sodium and chlorine aqueous. And there is our total ionic equation. Now we're going to cancel some things out. So sodium is exactly the same on both sides of our arrow. Chlorine is exactly the same on both sides of our arrow. Leaves us with our net ionic equation. I'm going to write the H first though. H plus AQ plus OH minus AQ gives us a water. And Na plus and Cl minus are spec ions in this neutralization reaction. Excellent. Moving on to the next one here. So we've got an actual titration question. So again, kids, this is not a dilution question because it's not one substance where we're adding water. It is two different substances. So we need to figure out which one we are going to find the moles of right away, and it looks like we have a volume and a concentration of the sodium hydroxide. So that is going to be our starting point. We're going to get the moles of the sodium hydroxide. So our concentration is 0.1, and our volume is 60, which I'll divide by 1,000 to turn it into liters. 0.06. Multiply those together and we should get 0.006. And I also recommend that we indicate that this is moles of NaOH. So let's carry that mole number into our next part of the question here. And in our next part of our question, we are going to find the moles of the HCl. So let's do that. So step 2, moles of HCl. And we'll carry on our one number that we have, which is the moles of NaOH, X and a line. Our balanced equation, we got a couple of ones in front of both substances, which is absolutely fine. 1 mole NaOH, 1 mole HCl. So we will switch from talking about moles of NaOH to talking about moles of HCl. Right, there it is. And lastly here, we need to figure out our concentration, knowing our volume. So our concentration is N over V, 0.006 moles divided by 0.025. That is my 25 put into liters. And when you divide that out, we should get 0.24 molar. So that should be our concentration of our HCl in this titration question. But we're not done. Now what we need to do is we need to go ahead and we have to determine the pH of both solutions. Alright, so let's start with the pH of the base because it's given right here. I mean, our concentration is given right there. So for NaOH, we're going to take our negative log of that molarity, 0.1, and we get an answer there. I think we should get an answer of 1. And we ask ourselves, does that fall into the basic range? Of course it doesn't. In which case we need to go 14 minus our answer, so 14 minus 1 gives us 13, and that definitely falls into the basic range. For the HCl, we just figured out it had a concentration of 0.24 molar, and we do the negative log of that value, and we should get 0.62, and that is definitely in the acidic range, so we shall leave that one alone. Alright, on to the next question here. We need to do our net ionic equation stuff. So with this one here, we've got a 2 in front of the sodium, so we'll take care of that right away. So 2 Na plus AQ plus. Don't forget that 2 applies to both of the ions here. That's why there's 2 OHs. Moving on to the next one, we've got a 2 with the hydrogen, so we're going to put that 2 in front now. So that subscript becomes our coefficient, SO4 aqueous. Going to the other side of our equation, we've got a 2 at the Na, so 2 is now our coefficient, SO4 minus 2 aqueous, and plus 2 H2O liquid. Because it's double displacement, there should be 2 spectator ions, and there they are. So wrapping this one up, I'm going to put that first because it's plus. So 2 hydrogens are going to find 2 hydroxides, and together they're going to make 2 H2Os. And we've also got our Na aqueous and our SO4 minus 2 aqueous as spec ions. That's that. 2b, titration. We've got enough information about our sulfuric acid to come up with our moles. So N is equal to C times V. Our concentration is 0.15, and our volume is 20. We'll make that into liters, 0.02. So a little multiplication there, we should get 0.003, and that is moles of sulfuric acid. In part 2, we want the moles of the other substance, which is sodium hydroxide. So let's get the moles of NaOH. We'll carry along our number, which is moles of H2SO4, X in a line. Let's remember from our balanced equation, we got a 2, we got a 1. So let's put that 1 mole of H2SO4 on the bottom. Excuse me, so we can cancel it out. That's going to play well. And we've got 2 moles of NaOH up top, so we're just doubling our number here. And we got our moles of NaOH. So let's use that number to solve for our concentration. So concentration equals N over V. We just found our N was 0.06. And our V is right there in the question at 10, which of course will change to liters. And when you divide those two out, you get 0.6 molar NaOH. We're going to use that to figure out our pH. I think what I'm going to do is actually combine questions C and D, because C is asking us to do our Arrhenius method for sulfuric acid. There's actually a point to this. So when you write out your Arrhenius method here, you'll notice that you get 2 H pluses, and those 2 H pluses have an impact on our concentration here. Because when we're doing pH, we're actually supposed to be doing the concentration of this value here. You may think we have done this one in the past, but it should be our H pluses. So when it comes to our concentration here, though, there in our question we actually started with a concentration of 0.15 molar. So you're probably under the impression that would be the number we need to take the log of. But if there are 2 H pluses, we actually have to double this 0.15. The concentration of this should actually be 0.3 molar. That's actually the number we need to take the log of. So when we do our pH formula here, negative log, we actually do need to do it of 0.3 molar because there were 2 hydrogens here. We double our concentration. If there were 3, we'd triple it. If there were 4, we'd quadruple our number. And when you do the negative log of that, you get 0.52. And that should be in our acidic range, and that one's good to go. Now you're wondering, does the same idea apply to the base? Well, we'll go ahead and do the base. You'll remember that the concentration of our base that we found was 0.6. So when we go to write out our equation here, we've got our NaOH, and we've got 1 sodium, and we have 1 hydroxide. So for every one of these, we have 1 of those, which means if our concentration is 0.6 molar for that, it's also 0.6 molar for that. So we will in fact be taking the negative log of 0.6 here. And when you do that, you should get an answer of 0.22. Does that fit into our basic range? No, it doesn't. That's in the acidic range. So we have to adjust this one. We have to make it into the basic range by subtracting those two values, 13.77. And that should be our final answer for that one. Okay, let's write a balanced equation here. So we've got barium hydroxide, and we've got H3PO4 aqueous for our phosphoric acid. It's an acid and a base, so we know that H2O gets formed. And we've got barium and PO4 coming together for our other product, so it's going to be barium phosphate. We got some balancing to do. Now, I should point out that we have 3 bariums here, so we're going to put a 3 in front. We've got 2 PO4s there, we're going to put a 2 in front. And if you go ahead and count up all the hydrogens there, we end up with 6 hydrogens in total. And that would be your balanced equation. Now we're going to have to now proceed and break everything up. So for our total ionic equation, we've got 3 bariums. We've got 6 hydroxides. Wait, what do you mean 6? We got 3 and a 2. We've got 2 per molecule. We've got 3 molecules. That makes 6 OHs. Same idea here for the hydrogens. We've got a 3 and a 2. That makes 6 hydrogens. And 2 PO4s. Here we've got 6 H2Os that we won't touch. And it looks like we have 3 bariums and 2 PO4s. And because it's double displacement, we should have 2 things that are exactly the same, and we do. Let's go ahead and start with that. So 6 hydrogens find 6 hydroxides, and they make 6 waters, no surprise. And the 3 bariums and the 2 PO4s are the spec ions. Now it's titration time again. Right here you'll notice we have enough info to find our moles of the acid. So we've got a concentration of 0.25. 35 mils is 0.035 there. Multiply those together, and I believe you find that number, and that would be moles of H3PO4. Great. Let's get the moles of the other substance, which is barium hydroxide. So moles of barium hydroxide equals 0.00875 moles of H3PO4. X and a line. Our balanced equation that we had on a previous slide had a 3 in front of the barium and a 2 in front of the acid. So a 3 and a 2 is what we're going to need here. So I think we had 2 moles of H3PO4 on the bottom, cancel, cancel, and 3 moles of barium hydroxide up top. So multiply by 3, divide by 2, and we should get 0.013 and a few other numbers there. Okay, let's carry that number forward into the last part of our question, because the last part of our question, we haven't answered this yet. It's saying determine the concentration. So let's get our concentration formula out there. Let's take our calculator, our number on our calculator, I should say. And we got 100 mils, so that's going to be 0.1 molar. And you divide this out here. I didn't do that right. Let's try that again. You should get 0.1. 3125, a few other numbers here. So let's go ahead here and let's do parts C and D together. We've learned from the previous question that we have to do a little bit of multiplying when we've got some compounds that are a little more complex here. So let's start with the phosphoric acid. We're going to do the pH of the phosphoric acid. So when we write out our phosphoric acid, it's got 3 hydrogens per acid, meaning we're going to have to triple our concentration. So jumping back to our question, what was actually our concentration? Our concentration of our acid was 0.25. So coming back to here, if this is 0.25 molar, then it's got to be 3 times as big here. It's got to be 0.75 molar. So that's the number we're going to do the pH of, in fact. The negative log of 0.75 molar. And so you do that, you should get, if my mathematics is correct, 0.125. Is that in the acidic range? It sure is, so we can stand pat with that one. On to the base. The base we were using was barium hydroxide. We have 2 hydroxides per molecule. There they are. There's the 2 hydroxides. So, I guess we found in this question, that was the whole point, was to find that this had a concentration of 0.13 molar. So this must be double it. This must be 0.26 molar, because there's twice as many. There are 2. So when we go to do our pH, we'll do the negative log of 0.26, and we'll get an answer of 0.6. And then we'll say to ourselves, well, this is a base, so we have to correct this by going 14 minus our answer, 0.6, and we should get 13.4 as our final answer for the pH of the base.